Hi everybody, Mr. Wyatt here, and today we are reviewing for the topic 8 assessment, which we will be taking the next time that we have class. So as always, I've created a video that is going to go through how to do each of the problems on this review. There are only 15 questions, and there will be 15 questions on the test on the topic 8 assessment as well. So let's look here at the first problem. A restaurant serves 3 different meals, 3 different drinks, and 2 different desserts. If you can choose one option from each category, how many possible meals does this restaurant serve? There are actually a couple of ways you can do this. One way is just to look at the total number of options for each category. We have 3 different meals. We have 3 different drinks. One of those drinks is water, so I'm assuming it would be bottled water. If it were just a straight water, they probably wouldn't charge you for that. And there are 2 different desserts. If you remember with the counting principle, you can actually just multiply those together. If you're choosing one option from each category, to find the total number of possible meals, you could just take 3 times 3 times 2 to find out the total number of possibilities. 3 times 3 is 9, and then 9 times 2 is 18. So there are 18 possible meals here. Now, since we have a tree diagram showing all of these options, here we have our hot dog with 3 different beverage choices, and off of each of those 2 different dessert options as well. Here you have your burger and your pizza. You could go to this last column right here and just count everything up. So we have 1, 2, 3, oops, 3, 4, 5, 6, oops, it keeps trying to cut in on me here, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you can see we have 18 possible meals here when you count up all of these, where it's alternating ice cream and cake in that last column. There are 18 of them there. Okay, so we do have 18 possible meals: hot dog milk ice cream, hot dog milk cake, hot dog water ice cream, hot dog water cake, and so on and so forth. And you do have a total of 18 possible meals. In number 2 now, if you can choose one option from each category, it's the same exact meal choices here as in number 1. How many possible meals can be ordered that include soda? Here's your key, that includes soda. And I know what you're thinking. You're thinking, oh, come on, this is Minnesota, man. We don't call it soda, we call it pop. Well, that's what they're talking about, though, is they're talking about your soda pop. All right, so how many meal options can be ordered that include soda? You know, soda is one of 3 drink options here. You have milk, water, or soda are your 3 options. So if you remember back to number 1 when we had 18 possible meals, if you find 1/3 of that, 1/3 of your options have soda. 1/3 has water and 1/3 has milk. To find 1/3 of something, you could just divide by 3. And 18 divided by 3 would equal 6. So there are 6 possible meals. That includes soda as the beverage. Okay. Now you could also go right through here and just find them. Like here's the hot dog and soda, which off of it has 2 different options, ice cream or cake. Here's soda here off of the burger with 2 possible options, ice cream or cake, and soda here as well with 2 possible options for dessert off of that if you're having it with your pizza. And 2, 2, and 2, add those up, you get 6 possible meals that way. So you can actually go right to the tree diagram and find those. Hot dog, soda, ice cream, hot dog, soda, cake. Burger, soda, ice cream, burger, soda, cake. Pizza, soda, ice cream, pizza, soda, cake. Those are the 6 possible meals that would include a soda. All right, now number 3, now we're looking at a die. We call these number cubes in math class, but it's a die. It has 6 faces. They're numbered 1 through 6. That's a standard number cube. All right, so we toss the number cube. What is the probability or likelihood, you could say. That means the same thing as likelihood. What is the probability or likelihood of rolling a number less than 7? Well, they're numbered 1, 2, 3, 4, 5, or 6. Aren't all 6 options less than 7? So we have a 6 out of 6 probability that we're going to roll a number that's less than 7. And when you write that so it's not written as an improper fraction, that would be 1 whole, wouldn't it? So actually 1 is our probability. Something that is guaranteed to happen has a probability of 1, okay? Something that's impossible, it could never happen, has a probability of 0. And anything in between we could express as a fraction, as a decimal, or as a percent. But yeah, it's guaranteed that this will happen. We will roll a number less than 7, so 1. All right, number 4, we have a game. It involves spinning the attached spinner. You can see it right here. What is the probability of the pointer landing on R? You can imagine R standing for red, Y yellow, G green, and B blue. Okay, I didn't have colors in this particular spinner, so I just have those letters there. And what is the probability of the pointer landing on R? Well, how many of the sections have an R in them? 1, 2, 3, 4. Out of how many total sections? 5, 6, 7, 8. We do have a total of 8 sections. So 4 out of 8 of them have the letter R in them. So the probability of the pointer landing on R is 4 out of 8. Now we can simplify this because these are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So there's a 1 in 2 chance of landing on R. Now that's a 50% chance. As a decimal, that would be 0.5. Okay, so these are just the different forms that we could use when writing the probability of landing on an R. It's either 1/2 or 50% or 5/10. All right, number 5. A bag contains 4 red marbles, 3 white marbles, and 7 blue marbles. So 4 red, 3 white, 7 blue marbles. You pick a marble without looking. That makes it random. That makes it completely random. Find the probability of drawing a red marble. Well, we have 4 red marbles. Out of how many marbles altogether? Well, I can total these all up to see how many marbles we have in this bag. And 4 plus 3 is 7. 7 and 7 is 14. There are 14 total marbles. 4 out of 14, I'm going to write it as a ratio here. So it looks like a fraction. There's a 4 in 14 chance of grabbing a red marble. Now, you'll notice that is not one of our answer options here. And that's because we can simplify this. We can divide the top and the bottom both by 2. So I'm really dividing by 2 halves, which is 1 whole. If you divide something by 1, are you going to change its value? No, you're not. But you are expressing it in simpler terms. So let's see what that would be. 4 divided by 2 is 2. 14 divided by 2 is 7. So we have a 2 in 7 chance of drawing a red marble, which is this answer choice right here. 2 out of 7 chance. All right, number 6. Look at this attached table. It's a drink survey. We have drink A, B, C, D, and E, and we have the number of shoppers that chose each drink as their favorite. Okay, the table shows the drink preferences of 50 shoppers at the mall. What is the probability in simplest form? That's important. We always want it in simplest form though. That one shopper selected at random from the 50 who were surveyed preferred drink D or drink E. So you ask them at random of the 50 people surveyed, and they said either D or E was their favorite. What's the probability of that happening? Well, if you look at D here and E here, it's these two options right here. You have to total those together, 11 plus 14. which means there are a total of 25 people who were surveyed who said they preferred either drink D or drink E. That's 25 out of 50 if I write it as a ratio. And all of my answer choices are written as ratios or fractions. So in simplest form, well, 25 goes into 50 twice. I can divide these both by 25. 25 divided by 25 is 1. 50 divided by 25 is 2. So it's 1/2. There's a 1 in 2 chance. The probability of selecting one of the people who were surveyed at random, the probability of them saying either drink D or E is 1 in 2, or 50%. And again, as a decimal, that's 5/10 in all of its various forms. Yeah, there's a 50% chance. 50% of the people liked either drink D or E. All right, number 7, a standard number cube with the numbers 1 through 6 is rolled. Find the probability of rolling a number that's less than or equal to 6. Well, the numbers that you'll find on a number cube or a die are 1, 2, 3, 4, 5, and 6. So what's the probability of rolling a number that's less than or equal to 6? So we want a number that's less than or equal to 6. Well, that's all of them again, isn't it? Because if it equals 6, then it fits the criteria here of being equal to 6. If it's less than 6, the rest are all less than 6. So it's guaranteed to happen. It's guaranteed to happen. So the probability again is 1. There's a 6 out of 6 chance this will happen. And when you divide 6 by 6, you do get 1 whole. So something that's guaranteed has a probability of 1. If it's impossible, it has a probability of 0. All other probabilities are in between those two. Number 8. Again, a standard number cube or a die with the numbers 1 through 6 is rolled. Find the probability of rolling a number that's greater than 1. So the probability of rolling a number that's greater than 1. Well, when you look at those options, you're going to roll a 1, 2, 3, 4, 5, or 6. Which ones are greater than 1? These 5 right here. This is the only one that's not greater than 1. Okay? So that would be a 5 in 6 chance, which is this one right here. 5 out of 6 chance. That's your probability. Okay? Now, if you were expressing this as a decimal, I believe that would be 0.83, and the 3 would repeat. I should put a 0 in front of that. Or 83.3 repeating percent. So it's pretty likely that you're going to roll a number that's greater than 1. There's a 5 in 6 chance you'll roll a number that's greater than 1. There's a 1 in 6 chance that you will roll a 1. All right, number 9. The probability of winning a game is 45%. I could say it like this. Probability, P, of winning is 45%. Probability of winning is 45%. How many times should you expect to win if you play 20 times? So we're going to play the game 20 times. 45% of the times that we play, we should win. So what you're going to want to do, did you hear me say of kind of loudly there? That's because of is an important word. Of means times. Okay? When you see the word of, that means times. When finding percents, we always multiply. Just change your percent. We're finding 45% of 20. Change your percent into a decimal. So 0.45. Remember, you just move the decimal point left 2 spaces to change it into decimal form. Of means times 20. and it's fine if you want to use a calculator for this. But if you take 0.45 times 20, you get zeros here. But then 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. You get 900, but then you move the decimal point in 2 spaces. You get 9.00, or 9 times. Okay, that's it. I'll see you later.